Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. So today our group will be presenting on the second assignment of Power System Engineering entitled Underground Cable Locating the Exact Location of Faults. So in this presentation, we will be discussing on two methods of locating the exact location of faults, which is Murray loop test and thumping method. So my name is Mohamad Zahin bin Mohamad Zahir.
My name is Ahmad Fikri bin Dahari.
My name is Mohamad Adib bin Zulkifli.
Introduction. Underground cables are employed for transmission and distribution of electric power where it becomes impracticable to make use of overhead construction. Such locations may be congested areas where right-of way costs would be excessive or local prohibit overhead lines for reason for safety or around plants and substations or crossing of wide bodies of water, which for various reasons would not permit the overhead crossings. The type of cables used will depend upon voltage and service requirement. Recent improvements in design and manufacture have led to the development of cables suitable for use at high voltages. This has made it possible to use underground cables for transmission of electric power for short or moderate distance. One of major limitations of cables is that fault detection, since the cables are laid under the surface, which is directly or inside pressurized ducts. The visual methods of inspection don't work effectively. This is not the case for over lines. Faults of ring cables are these three, which is open circuit fault, short circuit fault, and earth fault. So before we proceed deeper into the methods of locating the exact location of faults, let me briefly introduce to you the faults occurring in cables. So the first one is open circuit fault. This is the most common problem with underground cables. When one or more cables, the force break, it leads to discontinuity. This discontinuity also occurs when the cable comes out of its joint due to mechanical stress. So, on side note, all these three faults can be measured by using a measure. So, measure the information we get is if there is an open circuit in the conductor, the measure will reach infinite when connected between the conductor and the earth. Second one is short circuit fault. It occurs only in multi-core cables when two or more conductors of the same cable come in contact with each other. Then this is called a short circuit fault. It's impossible to detect visually without taking the cable apart. A short circuit fault occurs when the individual insulation of the cable is damaged. We can also detect it by using a measure. So the observation we get is if the measure reads 0, it indicates that a short circuit fault has occurred between those two conductors. The third one is earth fault. When any conductor or cables come in contact with the earth, it's called an earth fault. This usually occurs when the outer sheath is damaged due to chemical reaction with soil or due to vibrations and mechanical crystallization. Is somewhat similar to a short circuit fault as the current again takes the least resistive path and flows through the earth. These two can be detected using a measure, and the result is if an earth fault is present, the measure will show nearly zero reading. Difficulties. In underground electricity distribution systems, the cables used are placed in the ground or in some form of ducts. These ducts are used for insulation and also to protect them against harsh weather conditions. This makes the cables strong and the chance of fault in them very little. However, even insulated cables start to age, and when it happens, the production efficiency will decrease. So whenever there is a fault in these cables, it becomes very difficult to locate and repair the fault as conductors are not visible to the eye. Due to the location beneath the ground, it is not easy to locate the exact location of a fault, which means that problem will often fester for a while before they are fixed. Finding the type of fault in underground cables using a measure should not be a difficult task, but finding the exact location of the cable faults needs special techniques. So there are many methods to locate the faults along detection methodology. technology and tactical items, which makes the task easier and less time consuming. However, do note that there is no single or a combination of methods that's the best. So there are different types of methods for different faults, which make it safe and efficient to locate the fault without damaging the code.
So let us look into one of the common and popular methods, which is Murray loop test. So let us go into the introduction first. Murray loop test is the most common and accurate method for locating earth faults and short circuit faults. So it is necessary to have sound good cable runs along the faulty cable, and it can detect earth faults and short circuit faults. These two are faulties. So for the first one, earth fault test, let us examine the graph here. So the first is the point A and B is a sound cable, which is the cable that goods, and the C and D is the fault cable, which is the cable faults. Earth faults occur at point F, and the D to B are connected with low resistance connection, which is the sound cable or fault cable are connected with the low resistance connection. So P and Q, which is two variable resistors, are connected of point A, which is P, and point C, which is Q, resistance. So the next is battery connected at point O with a switch K1, and a galvanometer connected between point A and C, and R is resistant from A to F, and S is also the resistance from C to F. So first, let us go into the procedure. So first, we need to balance the resistance of P and Q until the reading of the galvanometer reach 0. In balanced position, the equation can obtain is P over Q equal to R over S. Then we can expand it, and we got the final is P plus Q over Q equal to R plus S over S. So we can represent R and S with R lowercase, which is the R lowercase is the resistance of each cable. Then we can replace it with from the equation before, and we get P plus Q over Q equal to 2R over X. Then we can find the X, which is X is what we want. Okay, S equal to Q over P plus Q multiplied with 2R. So the total length of cable is L. So the resistance per meter will be R over L. Then we can replace it into the we can put into the equation. Then the final equation we can get is Q over P plus Q multiplied with 2L. L is the cable length. So note that the fault resistance does not affect balancing the bridge, but can lower the sensitivity if the resistance is high. So for the next ones, this is the circuit of the short fault test. This is exactly the same, but there is one significant differences, which is the battery terminal connected at point O, and another terminal is connected with another fault cable there. That's the only difference between the short fault test and the earth fault test. Another thing is exactly the same. So this is also the same like before. We need to balance the resistance P and Q until the reading of galvanometer shows 0, and the balance equation can obtain, and the final equation is P plus Q over Q equal to R plus S over S. If R is the resistance of each cable, then we can get R plus S equal to 2R. Then we can replace the R plus X with 2R into the equation. Then we get P plus Q over Q equal to 2R over X. Then we can arrange it so that we can find what is X, and then we can put the loop of length meters. So by inputting the value of resistance and loop length cable, we can detect the fault location. So this is the advantage and disadvantage of the Murray loop test. For the first one is the application of Murray loop test is the long distance, and the Murray loop test is also not that complex. It is actually less complex. So for disadvantages, first one is difficult to set the bridge as balanced. So we had to set it make the galvanometer equal to 0. The current separation through the cable would cause temperature rises due to high voltage or high current. If the resistor varies according to the temperature, then the balance is collapsed. So we need to apply less voltage or less current to these circuits.
For the next underground fault detection method is Thumping method. So for the overview, one of the oldest and most popular techniques out there is a technique called the capacitor discharge technique or thumping a cable. In this application, this technique is actually very straightforward and simple. Basically, this procedure requires noise to detect the fault. When a high voltage is supplied to a faulted cable, the high current arc will make a loud noise enough to be heard. So let's see for the working principle. Firstly, a device called the thumper or surge wave generator creates a high voltage surge which is launched out onto the faulted cable. This surge of energy will travel along the cable conductor. Then, if it reaches an area of dielectric breakdown or a failure in the insulating material, the transmitted energy will discharge through the gap and at the fault and discharge all of the energy through the faulted insulation. All the fault current will then come back through the neutral or shield on the cable back into the surge wave generator and then will be dissipated safely to earth potential. If a several thousand volt surge is sent into the cable and all the energy is discharged through the gap of fault, it is going to cause a small explosion. This underground small explosion will cause a percussion and sound wave to travel up through the layer of earth. As a result, a thumping sound can be heard on the surface of the ground. To locate the defect in the underground cable, the repair crew has to walk along the surface of the ground listening for this thumping sound. Once the fault is pinpointed, the crew will dig a hole and repair the faulted cable. Okay. A major advantage of cable thumping is that it can locate open circuit fault very accurately. Also, this method is easy to apply as well as easy to learn. This technique requires fairly minimum training of its instrument, such as safety training on how to properly handle the instrument, how to properly make connections, and how to set the various controls. Though the thumping method provides very accurate fault location, it has its own drawbacks. So for its disadvantages, firstly, applying this method for longer cables is extremely time consuming. It may take hours or even days to walk along the cable to locate the fault. Moreover, during that time, the cable is exposed to high voltage surge. Where the existing fault is located, the high voltage surge may weaken the insulation of the cable. Also, finally, this technique cannot find faults that do not arc over, or we can call as a short circuit fault. This is because there is just basically a constant current loop happening, which means there is no energy being discharged or jump across the fault cable. So there will be no sound and explosion happening.
Okay, so to conclude, the faults of underground cable is indeed very difficult to be found due to no visibility of the cables itself. So the various development methods are indeed very useful, but still it cannot be said the best. Even though the Murray loop test method are common, value loop test, which is another popular method, is more preferred because if resistance of the fault is high, the sensitivity of the Murray loop test is low, thus value loop test is more suitable. Thumping method is useful for the relatively shorter cables. For longer cables, the thumping method becomes impracticable. Many electrical expert suppliers accept some level of damage to the insulators for two main reasons. Firstly, if thumping method is used for a short period, so the cable insulation is damaged. Secondly, there is no existing technology which can be replaced in this method. So that's all from us. This is our list of reference. So that's all from us. Thank you very much for lending your ears. Assalamualaikum warahmatullahi taala wabarakatuh.